So let's talk about some AES stuff, which is electronic code book versus CBC. I think this is probably the most fun one to talk about, where you encrypt the penguin. Which, yeah, very artistic, exactly. Yeah. That's one word for it. All right, so anyway, so let's exit here just to be sort of tidy and clear. All right, and then go back into Python 3, where you can do it all in interactive mode. Now, I do need to download this penguin, so let me figure out where I am. In 141, okay, I'm going to right-click, save image as, and I'm going to put that penguin in, there. Okay, oh, AES, that's where I am. Okay, tux.bimp, okay. All right, and let's, I think I'm fine. Let's do this. Let's do ls and see if I have tux. I got to go into AES. All right. There, now I have tux right here. Okay, so I can go back into Python 3. Okay. All right, so now I have tux. And here's my start of this process. So this will import the AES encryption library and define a key, and I'm just using a simple key with 16 letters. And this will create a cipher object using electronic codebook mode. All right. Yeah, anyway. All right. And some Linux systems don't have this older crypto cipher, so you use PyCryptoDome, which is better, and that's what you'll learn if you use CryptoHack. I learned about PyCryptoDome. But anyway, my Mac seems to have this older stuff working, so I'll just stick with that. So now I have to read the image. You can just read the image with this, open it as F, and then read it. That will read it. And then you just press enter, and that reads it. So if I was to print clear, it would be a long string of bytes. That's the image. All right. So I can now encrypt it with this ciphertext, encrypt clear. But I can't do it because the same reason we talked about, it has to be aligned to block boundary, which is another way to say it has to be in blocks of 16 bytes. Now there's another reason why I wouldn't want to encrypt the whole thing, because if I did that, it would no longer be visible as an image because there's a header at the start of a bitmap, and you can see it if you look at it in, say, a hex editor. Let me just open up HexFiend. All right, and let's take a look at that image. If I open, here I am. I go to, say, Documents, and then above that, and then into 141 AES. Here's tux. Okay, if you look at a bitmap, see this stuff down here is the colors, just repeating blocks of identical color like the background gray. This stuff up here is the header. That includes the BM to tell you it's a bitmap, and stuff here that tells you about the width and height of the image and the number of colors and things like that. So if you leave this part of it intact, you could encrypt all the rest of it, and it would still open as an image. You'd only encrypt the color part. So it's about the first 48 bytes you have to preserve, and then all the rest can be encrypted. And there is no footer in this image, but that much knowledge of the structure of bitmap will help. So what I'm going to do is skip the first 48 bytes and encrypt all the rest, except for a couple bytes at the end I'll skip just to make it come out even. So if you take the length of clear, and the length of clear modulus 16, you'll see it is 2 bytes more than multiple of 16. So the cool thing to do is pick out the part I want to encrypt, which, thanks to Python, is just this. I can go from starting at the 64th byte and omitting the last 2 bytes. Now I'll get a multiple of 16. I'll leave the header alone, and I'll skip 2 bytes at the end. So I'll encrypt pretty much the whole image except for one little dot in the corner. All right, and so now I can encrypt that part of it. So the ciphertext encrypts the trimmed part, and that's an integral multiple of 16 bytes, so it will go. And now I can just combine them all. So this will take the first 64 bytes of the unencrypted stuff, add all the encrypted stuff, and then put in the last 2 bytes of the unencrypted stuff, so it'll reproduce an image the same size as the original, and it will still be interpreted as a bitmap so I can view it, but the internal part of it will all be encrypted. And now I write it out as tux ecb.bitmap writing, just write that ciphertext. And that's it. So now if I go to here, I can go to Documents, and above Documents, here, and then 141 AES. So here's tux. Okay. And here's tux ECB. And you see it had the desired effect. All these solid blocks of color turn into solid blocks of color. That's what electronic codebook does. And I can do CBC with just adding an initialization vector and then creating CBC type cipher object instead. So I'm using IV, which can just be anything, and it has to be 16 bytes long though. And now I create a CBC object, and now I just encrypt this stuff again in that new mode, cipher blocks chaining, and then reconstruct it and write it out again. That's why I love Python. It's so easy. You don't even need to make much of a program at all. This is the same thing. Keep 64 blocks of the plain text, put in the CBC encrypted stuff and 2 blocks at the end, and write it out into this file. So now I've got that file, tux CBC, and that's the one that's completely scrambled. So that's the fun of cipher block chaining, seeing the weakness, why cipher block chaining is better than electronic codebook. All right. So there's that one.